Hey everyone, this video is going to be about positive and negative numbers, specifically how to deal with multiplying, dividing, adding, and subtracting when you have both positives and negatives. Okay, so the good news is when you're working with multiplying or dividing, the rules are very straightforward and very clear-cut. Whether you're multiplying or dividing two numbers, if you have a positive number, and I'm just going to use a star here to indicate multiplication, same rules apply for dividing. If you're doing a positive times another positive, then your result, your answer, is going to come out to be a positive. And we know that because that's all the numbers that we've ever learned so far leading up to our study of negative numbers. So for example, if we have 8 times 5, 8 times 5 is going to give you 40, or you can say positive 8 times positive 5 will give you positive 40. And I want to note here that sometimes when we're indicating multiplying, we'll do the dot to indicate that we're multiplying these numbers. We'll do parentheses, which is a common thing when we have negatives. Or sometimes I catch myself using a star a lot of the times to indicate multiplication. And again, if we have things other than numbers, like if we have a variable like x or n, then sometimes you don't see anything at all. If you have 8 times x, you might just see 8x. All of those mean the same thing. They mean that you're multiplying the two values. So, going back to the positives and negatives, if another situation that we'll have is a negative number times a negative number. And that every time is actually going to lead to also a positive number. So we might have negative 8 times negative 5. We've got two negatives multiplied by each other. Our answer is going to come out to be still a positive number. And a way to remember that is we kind of act like you know how when we speak the English language, if we have a double negative, like if we say I am not doing math right now, that means that I am in fact doing math. The two negatives almost cancel each other out. A double negative. And then the only other situation you'll have is if you have a positive number times a negative number, then the answer to that is all going to be negative. So for example, I could have positive 8 times negative 5. That's going to give me a negative 40. And then I could have a negative 8 times a positive 5. That's also going to come out to negative 40. So again, the value is the same. We're really just doing 8 times 5. But the sign, it just depends on these three. Well, really, there's two rules here. And we can kind of summarize that. We can kind of say, let's say it this way. We can say, for multiplying and dividing, if our signs are the same, if they're both positive or they're both negative, our answer will always be positive. And if our signs are different, we've got one is positive and one is negative. Doesn't matter which one is which. As long as we have one that's positive and the other is negative, then our answer is going to be a negative. Okay, so just remembering that rule is going to give you the right answer each time, anytime you are, again, multiplying or dividing. positive and negative numbers. So when we deal with adding and subtracting, that's when we have a few more things to cover here. And let me go ahead and switch colors. So let's say, okay, adding and subtracting positives and negatives. This can get tricky because the rules are not as clear-cut. It's not every single time you have a positive plus a negative, it's not always going to be either one, positive or negative. But what we can do is we can remember a number line. So let me go ahead and make a number line here. I want to make this kind of big. I'm going to try my best to draw a straight line. That's good enough. And then again, for a number line, we have to remember we think of 0 as being sort of in the middle of positive and negative numbers. So if we're dealing with numbers that are increasing, we have, we'll go just each one of these tick marks here will indicate 1. So we'll have positive 1, positive 2, positive 3, positive 4, 5, 6, and so on. Then to the left of 0, we have all of our negative numbers. And the further they get away from 0, the larger the value. So again, right here next to 0, we have negative 1, but if you move left, now we have negative 2, negative 3, negative 4, negative 5. So the value is increasing the same way it did moving to the right, but now our numbers are negative. So like negative 100, for instance, would be very far away from 0 on the number line, way down here, negative 100, whereas positive 100 would be way on the other side. So one thing that we can take a note of here, if we're adding a positive number plus another positive number, it does come out to be positive. But a better way of thinking of that is the first number that you're looking at, think of that as being a starting point on the number line. And then on the right side, think about how are we going to move on the number line. So adding a positive number actually indicates that we're going to move increasing on the number line, so moving to the right. So if we can visualize this here, let's see, let me get a blue. Say we have, for example, say we have 2 plus 3, right? So we're starting off at the number 2, positive 2 on the number line, and we're adding 3 to that, or we're going to move to the right 3 places. So 1, 2, 3, we're going to end up here at positive 5, right? 2 plus 3 is 5. Now, if we're adding a negative number, okay, let's say if we add a negative number to anything, whether it's positive or negative, that's going to indicate that we're moving opposite, that we're moving to the left. So if I said 2 plus negative 3, okay, I'm still going to start at a positive 2 right here, but instead of moving to the right, increasing, we're going to move to the left. So that's going to look like 1, 2, 3 spots over to the left. I'm going to end up at negative 1, and that's our solution, negative 1. So it's a lot easier with positives and negatives to think of where are we starting on the number line, and then how are we moving? Are we moving, how many units are we moving to the right or to the left? So to finish this list out over here, we had adding a positive moves to the right, adding a negative moves to the left. If we subtract a positive number, Again, we've done that from the start. Subtracting a positive is the same thing really as adding a negative. So that's going to be a move to the left. Our number is going to get smaller. It's going to decrease. And then the last possibility here is if we're subtracting a negative. So subtracting a negative is the same thing as adding a positive. It's going to be a move to the right. So let's look at a few more examples of that. Let me see. So, and I made a note here in orange on subtraction. Subtraction is just the opposite of addition. So if I have a number, if I have an example here like, let's say we have 5 minus 7. Okay, they're both positive numbers, but I'm subtracting, which indicates that I'm going to be decreasing my number. I'm going to be moving to the left on the number line. Let me make a new number line here to just show this. So again, we have 0. Let's do 1, 2, 3, 4, 5, 6, 7. And if you're in doubt, it's a good idea if you can just draw out a number line for your problem. Sometimes when we have really large numbers, we can't always do that, but I'll get to sort of a shortcut here in the first place. So again, 5 minus 7, the idea of that is that we are starting at positive 5 on the number line, but we're decreasing by 7, so we're going to move 7 spots to the left. 1, 2, 3, 4, 5, 6, 7. And where do we end up? We end up at negative 2, which is our solution here. But another way to think of that, an equivalent way of saying that is 5 minus 7 is the same as 5 plus negative 7. Because again, when you're subtracting a positive number, it's the same thing as adding a negative number. It's the same idea. Both of these indicate that we are decreasing, that we're moving to the left on our number line. So, let's see. Another example, let me do that here in a different color. Say we have, say we'll start at maybe positive 3, and say subtract negative 4. Right. So we have positive 3, take away or subtract negative 4. As I've indicated before, minus a negative is the same thing as saying plus a positive. So here we're starting at positive 3 on the number line. But this subtracting negative 4 is the same thing as saying add a positive 4. These two negatives here indicate that it's actually going to be plus a positive. So I start off with 3. I move to the right 1, 2, 3, 4 units, end up at positive 7. So that's a helpful way of remembering all that. And let me kind of go back up here. Is remembering wherever you start on the number line and then saying, how are we going to move? Are we adding a positive? We're going to move to the right. Adding a negative, we'll move to the left. And then just remembering when you're subtracting, it's the opposite move of when you're adding. So minus a positive moves to the left, and minus a negative moves to the right. Now again, like I've said, sometimes we don't always have time to draw out a number line, and sometimes it doesn't make a lot of sense to do that. So say that we have another example, but say we have some pretty large numbers. Say we have something like, I don't know, 479 minus 512, right? So again, you're not expected to draw out a number line that has 512 little tick marks on it. That wouldn't be reasonable. So a way to think of that, though, in your mind, think, well, which one of these numbers is larger, and how is it going to affect when we move it on the number line? So here's what I'm saying. Don't need to draw out all the ticks, but if you visualize a number line, and here's 0. Say we have on the positive side, we're starting at 479. But we're subtracting 512, which is larger than 479. So when we subtract, we're going to end up somewhere on this side of the 0, right? We're going to have to subtract 512 spaces over. So our result is going to be a negative number at the very end. Or again, you can think of it like this. You can say 479 minus 512 is the same as saying 479 plus a negative 512. Those two mean the same thing. And so what we really want to do is we want to subtract the two values. We want to subtract 512 minus 479, and then we'll know at the end of our problem that because the 512 was larger, we're going to end up as a negative number. So let's do that. Let's say 512 minus 479. And we'll set it up just like a subtraction problem, right? Because we want the difference here. So if we can, let's see, 2 minus 9. So let's borrow. Let's make this a 12. Borrow this 0, so 12. That's going to be 12 minus 9 is 3. Here we've got a 0, so let's make it a 10 and borrow from this, which will be a 4. So 10 minus 7 also gives us 3. And then the last column here, 4 minus 4 is 0. So the difference between 512 and 479 is 33, right? And even if we're not confident of that, we do it on a calculator, subtract, we get 512 minus 479, you get 33. But we have to know that our final answer is going to be a negative, so it's going to be negative 33. And a good way of sort of summarizing the whole add and subtract idea is, we'll say it like this, say, step 1, let's say, let's rewrite. Whatever our problem is, we're going to rewrite it as an addition problem, right? So if it says, you know, like this one had a subtraction in it. If it says minus that positive number, we'll rewrite it as plus a negative number, just so we have everything straight. And what we can do here is, if they're both the same sign, so if we're adding two things that have the same sign, we're going to add them, keep the sign. If we're adding two positives, we're going to end up with a positive number. If we're adding two negatives, then we're going to end up with a negative number. But we're just going to add the, I'll actually I'm going to put in here values. It's actually something which is called an absolute value, but we can discuss that in another video. So if they're different signs, meaning there's one positive and one negative, we're actually going to subtract the values, or we're going to find out what's the difference between those two numbers. And then we're going to use the sign of whichever value was larger. Use the sign of the larger value. So again, let's look at a couple of more examples. So if I have a problem like, I don't know, let's say 7, let's say this is another example. Let's say 7 minus 9, right? I'm going to rewrite that as an addition problem, just because it's easier if it's all addition. And we'll say 7 plus negative 9. Right? If I'm doing minus 9, that's the same as saying plus negative 9. So I'm adding two things. I want to add, they are different signs. One's positive, one's negative. I want to go ahead and subtract their values, and I'll keep the sign of whichever is larger. So the larger value here is 9. So our final result is going to be a negative number. And what number is it? It's going to be 9, whatever 9 minus 7 is. That is 2. And because the 9 is a larger value, it's negative, our final answer is going to be negative. So again, 7 minus 9 ended up being negative 2. And you can do this whole problem with a number line. You can say, on a number line, let me plot out 7, and then move 9 units to the left of that. You'll arrive at negative 2. Again, this is a shortcut. In math, we always have a longer way of doing a problem, and then we have a shortcut. And that's what we're showing with this two-step process. Rewrite it as an addition problem, and then follow these rules right here. But if you get confused, you can always draw out a number line if that's going to work better for you. So let's say, okay, let's do another one. Say we have 5 minus negative 4. Okay, if I had forgotten, minus a negative number, if I rewrite that as addition, it actually kind of put these two negatives together, it becomes positive. So we're really saying 5 plus 4. Now we have an addition problem. Our signs are both the same, they're both positive. We add the values together. 5 plus 4 is 9. Our final value is positive 9. So no matter what your numbers are, this two-step process is going to work. If we want to see another example, let's say we start with a negative. Okay, say we have negative 11 plus negative 14, right? Again, our idea was to rewrite this as addition. It's already addition, so we don't need to do that. We've got this plus that, and they're both negative, so that means they both have the same sign. We're going to add their values up, and we're going to keep that sign. So this is really the same thing as saying, what's 14 plus 11? We're adding the values. That's 4 plus 1 is 5. 1 plus 1 is 2. And then keep the same sign that we had before. So negative 25. And that's it. Okay, kind of finish this off with one last example. Again, let's start with a negative number. Let's say we have negative 3, and we want to subtract 8. Okay. If we have subtraction, again, we can rewrite it as addition. So we'll rewrite it as negative 3 plus a negative 8. Okay, and now we use our same rules. We've got the same sign, they're both negative, so we're going to add these two values, 8 plus 3, 11. That's 11, and they're both negative, right? Negative 3, negative 8, so our final answer is going to also be negative. It's going to be negative 11. So, to review, sorry, I didn't mean to do that. To review, if we go back to multiplying and dividing, very simple rules. If we have the same sign, our answer ends up being positive. If we've got two different signs, one's positive, one's negative, our final answer ends up being negative. Sorry. Adding and subtracting, again, it's easiest to visualize that using a number line and say we'll start off at the first number. And remember that if we add numbers, we're moving to the right. If we subtract numbers, positive numbers, we're moving to the left. And then it's opposite. If we add a negative, we move to the left. If we subtract a negative, we move to the right. And that gives us kind of a shortcut that we can use if we have really large numbers, if we don't want to draw a number line every time. And that is rewrite all of our problems as addition problems. Okay. And then see if we have the same sign. If they're both positive or they're both negative, we add up their individual values and we keep the sign. And if they're both different signs, one's positive, the other's negative, we subtract. And then we use the sign of whichever value was larger. So we have to do that on this example down here when we had 7 minus 9. Again, we have same thing as 7 plus a negative 9. So we subtract the values. We actually take the difference, 9 minus 7. And because the larger number was the negative 9, our final answer is a negative number. So using those techniques, we're going to go ahead and just try out a lot of different positive and negative problems and make sure that we've got our signs in the right spot.